So, hello, this is Manas Pandey and I am from the BS Physics branch of IIT Kanpur and I am here to give a presentation upon the topic Secrets of the Pascal's Triangle for the Elucidate competition of the Science Coffee House of IIT Kanpur. So, let's start. So, many of you may already know, but still to point out, what's the Pascal's triangle, you may ask. So, actually, it's a symmetrical triangular arrangement of numbers in a very specific manner, and when and the it's a mathematical object, and it can provide a lot of value various sequences when we find out collect patterns from it in a very specific manner. For example, if we go to the second diagonal, we can find out that it's the sequence of natural numbers. Yeah, so 1 2 3 4 5 6 7 8 9 10 in both ways, left or right, you can go from this side too. So I will talk about these sequences later on, and these are specifically the secrets of this triangle. So so let's continue. So this triangle is known by many other names. For example, our Indian mathematicians of the early centuries used to call it the staircase of Mount Meru, and people of Iran used to call this the Khayyam triangle, and in China it was named the Yanghui's triangle. So a little history about this triangle won't hurt, I guess. Yeah, mathematicians don't like to discuss history, but still, actually, this triangle was originally named after the famous mathematician Blaise Pascal, and he was very famous, and his works are credited all over the world. He was even the first, I think, the first inventor of the modern digital calculator. So you know how important he was. So, and he used this triangle in many of his works. So that's why he had kind of advertised and made it famous. So, and actually, this triangle, the story of this triangle dates even far older than the birth of Blaise Pascal, about 600 years ago of this. So it was devised by the Chinese mathematician Jia Jiang, and he was the one who first found it out. But actually, Yang Hui was one of the mathematicians in China who successfully advertised this in the people of China for to the people of China. So yeah, there's after that, even after the discovery, about has been about 10 centuries after that. So still now there are many secrets which are being discovered of this triangle, and it's used in many places. Nowadays it's also used in finding out some spins of some quantum uh, uh, equations and something. I don't know the exact terms, but still it's an important mathematical tool anyways. So how to draw this Pascal triangle? It's a very simple way to do it. So first we start with a 1, which is the first natural number, and we assume a 0 here, and then we can add 1 and 0 to get the next element. And similarly, for the next all elements, we can just add the top two elements and get the next. Like here we get 2, here we get 3, here we get 3, then 4 6 4, and so on. So it's not too difficult, and it's a very easy. We just need basic arithmetic to do it. So this is not a big of a secret, but we can devise the binomial coefficients for Pascal's triangle, and this is the thing about which many of us know. So individual bricks of this triangle, they represent a binomial coefficient according to the row in which they are present, and they are normally we call it the combination. So NCR, this is the first row, the second row. So in the, like for example, here we can see that I have written the expansions of these numbers. So that's 1. Then you can see the coefficients here. Like for, let's see, x plus y to the whole cubed. So it's x cubed plus 3x square y plus 3xy square plus y cubed. So you can see the coefficients. Here it's 1, here it's 3, here it's 3, here it's 1. So, and you can see it from the fourth row that this is so. So yeah, the second secret is also not that, again, a big one, but if you sum the elements of a specific row of this triangle, you find that they are equal to the power of 2. For here it's 1, so 1 is the 0th power of 2, and here's 2, and there's 4, and there is 8, and there is 16, and so on. Yeah, and it's also a good thing but it's good to know. This one I find a little fascinating, that you may also find the Fibonacci sequence in this triangle. So like if you go to the triangle diagonally and not the direct diagonal, it's a little slant diagonal. So you may find the Fibonacci sequence here, like 1 1 2 3. Here it is shown in a very it's shown in a very great diagram, in a great manner, so you can see this from. So yeah, and actually you can, but you may not know, but you can also derive the terms of the formula for the terms of general term of Fibonacci sequence through this triangle, and it's a little different than this. The method is a little different than how we devise this formula, but and if we take some assumptions, we can find out this too. So I think it's great that we can find this formula so easily due to this triangle, and it's a one of my favorite secrets which I know about this triangle, and I usually show it to people whenever they show interest in this concept. So now moving on. Yeah, there are also powers of 11 in this triangle. So in, you know what you have to do is, like, when you go through the row, you have to multiply the first number to the power of 10. Like, if the first number you have to multiply the power of 10, then second number to 1. So this is the ones place, this tens place. Similarly for this ones, tens and hundreds. For example, if there are numbers like this, you may carry over. So you get 1 5, then 0, then you carry over the 1, so you get 1 here, and 6 is when we carry over this 1 to 5. So you can find the powers of 11s when you add the rows in a very specific operation, do a very specific operation on the rows. And I find it also too great that 2 and 11 are connected in such a way. So yeah, usually we used to joke around, know that in 1 plus 1, if we add them together without any usually in coding or something, like if there are two strings, then we get 11, and if we add them as numbers, we get 2. So I find it very fascinating that 2 and 11 are both a part of this Pascal's triangle, and we use them in coding as, if we get them in coding if we add ones as strings or as numbers. So yeah. And yeah, you can also find primes in this. Primes are always one of the most fascinating things about mathematics, and whenever we find primes, we think that wow, means it's something great is going to happen for this. So if you go to the rows in which which are specific to the prime, like 2 3 5 7, you may see the numbers which are the other numbers except 1 in that row are always a multiple of that, means are always the multiple of that prime. But it's not so for the composite numbers. Some people think it's same for the but see here, it's 4 6 4. 6 is not a multiple of 4, but it's still in the row of the number. So I think it's also a great thing to know, but some people don't know. So that's why I'm showing these secrets, telling these secrets. So next, yeah, this is one of my favorite patterns which I found out about this triangle, and I love this. So it's called the hockey stick pattern, and it's very fascinating. And I don't know why it's named, but I feel that the sticks, when you go so like this, you find that it's like a hockey stick. So basically you have to pick an element and then go diagonally to it in the one direction, and whenever you stop, the best thing is that whenever you stop, like here you stopped after 3 elements, then you get 10, but if you may go one more element, then you get 10, then you get 20. Means if you go to another, then you get 20, but you have to move in the same direction. And when you want to turn, means when you just turn to the other direction, you found out the sum of these numbers. So if by chance you have to calculate that sum of 10 15 and means you have to calculate the sum of 1 3 6 10 15 and 21, then you get 56. So the best thing I think that about this, that when you need to find the sum of natural numbers, you can just go 1 2 3 then 6, 1 2 3 4 then 10, 1 2 3 4 5 then 15. You can do same for the triangular numbers, which I'll come after a little while, after some secrets. So yeah, but I think it's very great. Means it's kind of, I like this secret very much. Means and it same happens for other ways also. Like you can go from the middle to, like if you go 15 like some ways you can go in the middle to, but it's a little difficult to explain. But if you go straight from here and then go to right, I think there is a mistake in this image, but still if you go from here and then to the right, then you find 252. It's not just 2, so there's a mistake in the image, sorry for that. And then you know about the triangular numbers. Means triangular numbers are basically numbers which if you put 3 balls in a way, like let me draw and show you what I mean. Like if you put 3 balls they can form a triangle. Similarly, this happens with the 6 poles also. You cannot draw a triangle with 4 poles. So these triangle numbers are those numbers which can form a triangle when arranged in, like, I mean, 3 dots can also form a triangle, 6 dots can form a triangle, 10 dots can form a triangle, means similarly. So it's a great thing, I feel. So moving to the next. Sorry. The next is about the square numbers. So these are specific, means we can find these numbers by summing two numbers together. Means these are like, you can I have given an explanation here, and it's very great to know about this also, that if we get if we add 1 and 3, we get 2 to the power 2. If we add 1, 3 and 6, we get 9, which is 3 to the power 2. So the sum of 2 or 3 numbers gives out the square of the remaining numbers. Like we add 3 and 6, then we get 3 squared. 6 and 10, we get then 4 squared. So yeah, we get square numbers like this. Similarly, for 10 plus 15 is 25, which is 5 squares. So you can find squares in a very great manner. Like, sometimes if we go more even down, then we just have to add 2 numbers to get the squares, and we can prove this arithmetically also through by NCR, and it's an easy thing. But it's good to see that in a way in this triangle we can easily find it out. So 3 plus 6 is 9, so it gives 3 squares. Then 6 plus 10 is 16, that's 4 squares, and it's also a very great secret about this triangle. So next, many of you don't know about Catalan numbers, but actually it's a very specific number. Like, let me show you. Like if you were square, so how many ways can you cut a square? So you will find out, you can form 2 triangles, and actually for square there is only one way, and you can form out 2 triangles. You may cut it this way, or you may cut this way. You may think that you can cut twice, but we have to make lines so that they don't intersect. So here there are 2 ways. So that's why the Catalan number for a quadrilateral is 4. You can say the way to do is, like, you go to the middle number of the row, and then you subtract the number which is just left or right, means they are the same numbers. So you can subtract the number to the right, and you get 2. So 2 is the Catalan number for 4. Similarly, if they are hexagon, you may try to calculate, and you may, if you want, then you can Google it too. So for a hexagon, the Catalan number is 5. Means you can make triangles in hexagon 5 in 5 different ways, without intersecting. So yeah, means Catalan numbers can also be found by this Pascal's triangle, and this is also a great mathematical sequence. Yeah, this is one of the most beautiful things ever in mathematics and physics. Means you can find it, many of you may know about the Mandelbrot set, and it's a kind of fractal too. So fractals are very, very beautiful patterns. Like, this is not a great representation of what a fractal could do, but this is not a great presentation of what a fractal is, but you may Google about fractals. But if you means expand the triangle to many large numbers, then if you shade all the even numbers and all odd numbers in different colors, you will find that there is a very specific pattern forming. And this is also too very fascinating. Means this triangle is so beautiful that you can find even more beautiful things in it. So you can even understand you can see the beauty in mathematics. And this is, means I find fractals very interesting, and very, means they are so beautiful. Means I'm just in love with fractals. So let's talk next. Yeah, they are just like triangular numbers, they are tetrahedral numbers and pentalope numbers also. So they go with the 4th and the 5th diagonals. Yeah, it's as I have written here. So what are tetrahedral numbers? Tetrahedral numbers are just like triangular numbers. They are numbers which, when you can form tetrahedrals with with those numbers. So yeah, those are tetrahedral numbers. And yeah, pentalope numbers, you have got there are some 4-dimensional objects which we sometimes presume as pentalopes, and they can also be shown in 3 dimensions. So they are formed by 1, 5 and 15, means these numbers, and which so on. Where number over here come, like this comes 35 here. So yeah, so it's also great. So these are some of the secrets of the Pascal's triangles. There are many more, but I don't want to make this video too long, and I was not, means it was, I can do this much in this the given time. So yeah, this is the bibliography which I have used for these triangles. And thank you for watching, and may you like it. Thank you.